Alright, this is the Unit 7 FRQ test corrections. And on this one, I scored a 11 out of 15. So, number 1, part A says, the platform rotates with a constant angular speed, which if the above graph correctly shows the magnitude of angular momentum of the platform as a function of time, t about a vertical axis, at the center of the support rod. Briefly justify your answer. So I said that between graph A and graph B, it would be graph B because the angular velocity is constant, and that with the equation L equals inertia times angular acceleration, the constant velocity would make the angular acceleration also constant, and the inertia of an object is always constant unless that object is changing like shape or something. So you're gonna have two constants in that equation, and so the graph will be constant as well. So straight line graph. And so this one I got full points. For part B, the question asks, the platform rotates with a constant angular speed. Is a net torque exerted on the platform about its center clockwise, counterclockwise, or zero? Explain your reason. I said that the torque would be clockwise because it'll follow the direction of velocity of the system to try and balance itself. And actually, for this question for B, it says that the net torque on the platform will be 0. So I got -1 because the I didn't say that the net torque would be 0. I said that it would be counterclockwise. And I did get a point for saying that, what was it? Yeah, relating the angular speed to the angular acceleration for the second point. I did say that it'll follow the direction of velocity, and so that the velocity will be related to angular speed. Is angular, or when I said velocity, that meant angular speed, and angular speed that relates to acceleration. So I got a point there. And then 1 point is earned for correct relating. And then I didn't relate net torque to the angular acceleration. So yeah, I didn't really say that if the angular acceleration is 0, then the net torque is also 0. So that's why I didn't earn this point there. Part C says, as the period of rotation becomes very small, what value does theta approach? Without writing any equations or formulas, justify your answer. I said, as the period of rotation becomes very small, and assuming that the angular velocity remains constant, theta will approach 0, because in order to have a shorter time with each cycle with a constant angular velocity, you'll have to shorten the distance traveled, and by having theta approach 0, the distance will decrease, which is what we want. So okay. 1 point is earned for a statement that correctly relates the period to angular speed, and 1 point is earned for a statement that correctly relates angular speed to angle theta. Okay, so for this question, they assume that theta, or angular velocity, doesn't remain constant, which is that I pretty much said in my response. So I missed a point on relating angular speed to theta. And then I did get a point that relates period to angular speed, because I said that if it wants to go around the same distance in the same time, then the velocity will have to increase. All right, D says a student derives an equation for the square of the period of revolution t of the sphere as a function of d squared equals 4 pi squared L cosine theta over g. Indicate whether the equation is consistent with your answer in part C and explain. So the equation is not consistent because if you plug in values for the equation, like for L and G, for the theta, yeah, if you make everything else constant, make L and G constant, if you increase theta, then your period will decrease. Yeah, and this doesn't really make sense because this is basically saying that if you plug stuff in, it's basically saying that if you increase theta, then it'll take less time for it to go around in a circle and complete one cycle. And you'd think that it would take more time to complete a bigger cycle. So my reasoning, I thought it was fine, but it didn't really make sense here. But I did say that it was consistent with my response in part C. Because my part C also assumed that the angular velocity would remain constant, which the answer key didn't. So that was another factor to consider. And then, let's see. Yeah, my frame of, I did get a point for, let's see. Oh, in the answer key it says 90 degrees, as in when it's, okay, their frame of reference is weird, because when they said 9 degrees, I thought that meant when the object is here, but they actually meant when the object is here, it was 9 degrees. So yeah, we're basically saying the same thing, but we just have different perspectives on the where the 90 degrees was. So yeah, that's why my answer does show the dependence on the theta. And then I didn't really, I guess, explicitly say that here, so -1 for argument. Okay. Now for part E. Says, which graphs could you use to find, which graph could you use that you would use to find the slope, and the slope would equal to gravity. So you can do, just isolate the equation for G. So you do that, G is 4 pi squared times L cosine theta over T squared. And so you get T squared on this side, and on this side. You find the slope of this graph. The slope is equal to gravity, because that's what you graphed. Okay, part F. As the angular speed of the platform increases, does the period of revolution of the sphere increase, decrease, or stay the same? Briefly explain your reasoning. So as angular speed increases, period of revolution decreases. Obviously, because traveling the same distance with, is it traveling the same distance faster? Equals it'll be in less time, so I got 2 points for that. And so yeah, that's it. I got 11 out of 15 for my final score.